All right, so now we have that example 2 that I wanted you to try on your own. So if you didn't try it, pause this, try and set up the absolute value inequality on your own, and then watch this video. All right, so we know that the golf ball manufacturer puts 390 golf balls, so that would be your perfect. So if they packaged it perfectly, that's how many balls would be in the box. But it can be off by 6 golf balls. Okay, so this is what you're going to add, subtract. All right, so we're going to write an absolute value inequality that displays the acceptable amount of golf balls that can be in each box. Okay, so remember we always set it up with absolute value, x minus, and then the perfect amount. So 390 golf balls would be perfect. And since we know it's going to be a range where we add 6, subtract 6, we know that it's going to be less than. So it's going to be an and problem, less and, or great or. So it's not going to be an or problem because that would fall out of that range. This is the one that's going to give us an and problem. And then we're going to put 6. And then to find that acceptable range, remember you're just going to solve it, x minus 390. Flip the inequality, make it negative. Leave this one alone. We're going to add 390. So x is going to be greater than or equal to 284. Sorry, 384. And then add 390. Add 390. And x is going to be less than or equal to 396. So this should be either the range. So remember, this is an and. So we know that range is going to be, it's got to be between 396 golf balls or 384. And that would be a perfect range of what you could expect to be in each box. So hopefully that's what you got as well. And so that's what it was asking you to do, is set up this inequality. And this is it, just solving. So you know, if we had 385, that's an acceptable amount. If we have 394, that is an acceptable amount. But anything bigger than that or less than that would not be in that range. Okay, so same thing here. We're preheating an oven to 350 degrees. The measured temperature has an absolute deviation of at most 5 degrees. So it can't be off by more than 5 degrees. Write and solve an absolute value inequality that displays this acceptable temperature. All right, so we know we set our temperature to 350. It can be off by at most 5 degrees. So you can add 5 degrees to be 355, or you can subtract 5 degrees to be at 345 degrees. So as long as you're in that range, then you're all good. So you're going to do the absolute value of x minus 350 is less than or equal to 5. And so to solve that, once again, you just split it up, flip it, make it negative, leave it alone, add 350. So x is going to be greater than or equal to 345, add 350. So x is going to be less than or equal to 355. So it's going to be in between this range. So your numbers have to be between 355 and 345. So this is how you would set it up, and here is your answer. Okay, one more for you to try, and that is it for today's lesson. Hopefully we understand the absolute value inequalities a little bit better. Make sure you realize the 350 is the perfect. That's what's going to go inside with the absolute value, and the 5 is what's the change. So try this one on your own. A clothing designer is selecting models to walk the runway for her fashion show. The designer prefers models that are no more than 3 inches away from being 70 inches. Write an inequality that can be used to determine if the model's height x is in that range. So go ahead and solve that and pause the video, and I will tell you the answer in a second. All right, so hopefully you got that one done. To set up the inequality should be x minus, and you want that perfect height. 70 would be that perfect height. And then less than or equal to the change. So we're going to be that 3 degrees is what would be changing. You'd either add or subtract.